Hello everyone and welcome to AWS Analytics Services Decision Guide or the Selection Guide. This is one of the most important lecture of the entire course. I will go as far as saying that if you watch this lecture and pay attention, then you will most likely be able to answer all the analytics questions. Most exam questions will ask you to pick the right analytics services or the service, or will try to confuse or trick you into choosing between similar analytics services. So if you go through this lecture, then hopefully you will be able to tell the differences or similarities between the services clearly. So this lecture will contain all these topics: list of all the AWS analytics services, streaming, batch processing and ETL, data warehousing and data lakes services, business intelligence and visualization, data governance and collaboration services, search and discovery services, AWS analytics services master comparison table, AWS data streaming services comparison, AWS analytics query services comparison, AWS data processing and ETL services comparison, AWS orchestration services comparison, data governance and cataloging services comparison, business intelligence and visualization services comparison, search and log analytics services comparison, specialized analytics services, data storage and format optimization comparison, and lastly, exam-focused decision metrics. So first, these are the services which I'll be covering: Athena, Redshift, EMR, AWS Glue, Glue Data Catalog, Kinesis Data Streams, Kinesis Data Firehose, Managed Service for Apache Flink, Amazon Managed Service for Apache Kafka, Amazon MWAA, which is Managed Workflow for Apache Airflow. So workflows for Apache Airflow, QuickSight, Managed Grafana, Amazon OpenSearch Service, Amazon TimeStream, AWS Step Functions, AWS Lake Formation, Amazon Data Zone, AWS Clean Rooms, AWS Entity Resolution, and AWS Data Exchange. So streaming, there are 4 services. They are Kinesis Data Streams, Amazon Kinesis Data Firehose, Amazon Managed Service for Apache Flink, Amazon Managed Streaming for Apache Kafka. Streaming is the data which is non-stop. There is no bound. It's being continuously produced and there is no limit. There is no end or the start date. It's being produced non-stop. Batch processing and ETL. So batch processing is the data which can be processed in a batch. There is a clear start and end. There is a size which can be attached. So these are Glue, Amazon EMR. Earlier it was called as Elastic MapReduce. Then Amazon Managed Workflows for Apache Airflow, AWS Step Functions, Amazon Managed Service for Apache Flink, and data warehousing and lakes. So Redshift is the only data warehousing service. Others are lake formation or the data lake related. Lake formation, Glue Data Catalog, and Amazon TimeStream. So TimeStream is mostly for time series data. Business intelligence and visualization. So QuickSight, Amazon Managed Grafana, and Athena. Data governance and collaboration. So Data Zone, AWS Clean Rooms, and AWS Entity Resolution. Search and discovery, Amazon OpenSearch, Amazon Data Zone. So AWS Analytics Services Master Comparison Table. So this will be having all 20 services and what they do at a very high level. First, Athena. Processing pattern is batch, and this is data structure is structured or semi-structured. It's applicable. The query or the data model which we use as SQL, and architecture is distributed. Data storage is data lake query engine, the type of data storage. Processing type is OLAP, online analytical processing, or OLAP or OLTP. So there are 2 processing types. Primary use case is ad hoc analytics, log analysis, and S3 data exploration. Next, Redshift. So this is like a batch data near real time. So processing pattern, data structure, structured and semi-structured. So you can use this to query both of this. Query type or data model is SQL. Architecture is distributed massively parallel processing, MPP. Data warehouse and processing type is OLAP. Primary use case are enterprise business intelligence, complex SQL analytics, data warehousing. Next, Amazon EMR. Processing pattern is both batch and streaming. Data structure, all data types. Query and data model is framework dependent. Architecture, it's distributed database or the data analytics service. Data storage, big data platform. And processing type is OLAP and ETL, extract, transform, load, and ML, machine learning. Primary use case is big data processing, ML at scale, or custom framework of needs. Next comes AWS Glue. Processing pattern is batch and streaming. Data structure is structured as well as semi-structured. Query and data model is SQL, Python, and Scala. Architecture is distributed. Data storage, ETL service. Processing type, ETL. And primary use cases, serverless ETL, extract, transform, load. Next one, data cataloging and schema discovery. Next one, Kinesis data streams. Streaming type, processing pattern. Data structure, all data types. Query and the data model is not applicable. It depends on the storage layer. Architecture, it's a distributed service. Data storage, stream storage. Processing type, real-time ingestion, and primary use cases, real-time data ingestion, event streaming, and multiple consumers. Next, Kinesis data firehose. Processing pattern is streaming. Data structures, all data types. Query and data model is not applicable. It's a delivery service. Architecture, distributed. Data storage, stream delivery. Processing type, near real-time ETL. Primary use cases, stream delivery, and simple format conversion. Then comes managed service for Apache Flink. Processing pattern is streaming as well as batch. Data structured as well as semi-structured are applicable. Query and a data model, so you can use SQL, Java, Python, and Scala. Architecture, distributed. Data storage, stream processing. Processing type, real-time analytics. Primary use cases, complex event processing, stateful analytics, and time windowed analysis. Next, Amazon managed service for Kafka. Processing pattern, streaming. Data structures, all data types. Query and data model, not applicable because it's a messaging or some kind of a buffering service. Architecture, distributed. Data storage, it's a Kafka service. It's a managed service for Kafka. So processing type, event streaming. Primary use case, event backbone, stream processing foundation, or messaging. Next, we have Amazon QuickSight. Processing pattern, batch and near real time. Data structure, structured and semi-structured. Query and data model, SQL. Architecture, it's a centralized service. Data storage, BI service. Processing pattern, OLAP, online analytical processing. Primary use cases, business dashboards, self-service BI, and embedded analytics. Next, Amazon managed Grafana. Processing pattern, near real time. Data structure, structured and semi-structured. Query, data model, time series query. Architecture, centralized. Data storage, visualization. Processing type, operational monitoring. And primary use cases, operational dashboards, technical monitoring, and observability. Next, AWS Lake Formation. Processing pattern, batch. Data structure, all data types. Query/data model, it's a governance service. Architecture, centralized. Data storage, data lake governance. Processing type is data governance. Primary use cases, data lake security and fine-grained access control. AWS Glue data catalog. Processing pattern is batch. Data structured as well as semi-structured. Query and data model, not applicable because it's a metadata service. Architecture, it's a centralized service. Data storage, metadata repository. Processing type, data cataloging. Primary use cases, central metadata storage, schema discovery. Amazon Open Search Service. Processing pattern, near real time and batch also. Data structure, all data types. Query and data model, DSL, SQL, and PPL. Architecture, distributed. Data storage, search and analytics. Processing type, search and OLAP. Primary use cases, full text search, log analytics, observability, vector search. AWS step functions. Processing pattern, batch and event driven. Data structure, not applicable because it's an orchestration service. Query and data model, again not applicable, it's a state machine. Architecture, distributed. Data storage, workflow orchestration. Processing type, process coordination or the coordination service. Primary use cases, service coordination, multi-step workflows, and ETL orchestration. Next come Amazon Data Zone. Processing pattern, batch. Data structure, structured as well as semi-structured. Query and data model, not applicable because it's a discovery service. Architecture, centralized. Data storage, data discovery. Processing type, data governance, it falls under governance. Primary use cases, business-oriented data discovery and self-service governance. Next one, AWS clean rooms. Processing pattern, batch. Data structure, structured. Query data model, SQL. Architecture, it's a distributed service. Data storage, data collaboration. Processing type, privacy preserving analytics. Primary use cases, secure multi-party analytics. Privacy preserving collaboration. Okay, next one, AWS entity resolution. Processing pattern is batch. Data structure is structured. Query/data model is not applicable because it's an identity resolution kind of service. Architecture, distributed. Data storage, it's an identity resolution. So processing type, data matching. And primary use cases is customer 360-degree views, record deduplication, and ID resolution. Amazon time stream, processing pattern near real time and batch also. Data structure, so only works with structured data. Query and data model is SQL. Architecture is distributed. Data storage, it's a time series database. Processing type is time series analytics. Primary use cases, Internet of Things, IoT data, monitoring matrix, and time series analytics. Next one, AWS data exchange. Processing pattern is batch. Data structure, all data types. Query/data model, not applicable because it's a marketplace driven service. So basically there's a marketplace and you buy and sell your data assets. Architecture, centralized. Data storage, it's a data marketplace service. Processing type, data sharing. And primary use cases, third-party data discovery and data access. And lastly, Amazon managed workflow for Apache Airflow. Processing pattern, batch. Data structure, not applicable, it's an orchestration service. Query and data model, not applicable, it's a directed acyclic graph, DAG. Architecture, it's a distributed service. Data storage, it's a workflow orchestration service. Processing type is process coordination. Primary use cases, complex data pipelines and Python defined workflows. So Python is very important because it only supports Python at the moment. Okay, now I will go deeper and just compare the data streaming services so that you have no confusion when you see streaming related question. First, Kinesis data streams. So I already talked about primary purpose, real-time data ingestion and enable multiple consumers. Then under data processing, you have real-time streaming, ingestion and consumption. Latency and retention, low latency 70 millisecond to 200 millisecond and retention is 24 hour, 1 day to 365 days retention. Best for high throughput data ingestion with replay capability and multiple consumers. So this is one of the first service from AWS and it is one of the de facto for streaming. Only you will choose a different answer if there is additional information. Kinesis data firehose. It's a simple managed delivery, which is delivery of streaming data to destination. So basically you have some buffer and you finally there are targets or destinations where you want to deliver the data. So that case you will use data firehose. It's a near real time buffered service. Latency and retention near real time. So minimum you have 60-second buffer. There is no internal storage and it is best for simple zero code data delivery to supported destinations, and there are a lot of supported destinations, but it could be S3 bucket, Redshift or Athena or also QuickSight. AWS data streaming service. So next we have managed service for Apache Flink, and this is a managed service. So Apache Flink is a own project for streaming data. So now this has a managed service. Primary purpose is complex real-time streaming processing using Apache Flink. So basically it has a model where you can do real-time stream processing, and it can have complicated stream processing also, which is not there in the Kinesis data stream. So data processing is real-time stream processing, stateful analytics. Latency and retention, it's a very low latency, milliseconds. There is no built-in retention. Okay, it's best for complex stateful stream processing, event time analytics and windowing. So you see the difference is there is no retention compared to data streams. Next, Amazon managed service for Kafka. So again, this is Kafka for event streaming, but data processing is real-time streaming again, and PubSub, like publisher subscriber messaging. Latency and retention, low latency. It's a sub-second kind of latency, but bit higher than Kinesis data streams, and retention is configurable. So best is when you have Kafka kind of dependency, like there's Kafka compatible applications are or you are migrating, but you have to stick with Kafka, then only you will choose this. And it's a event streaming backbone. So basically it can it also do PubSub and all similar to streams, Kinesis data stream, but Kafka is involved. Next, analytics query services comparison. So we are going to next category. First, Athena, primary purpose serverless SQL querying. Data location, data directly sits in on S3. So schema on read. So Athena does not store its own data. So finally, it's been read from S3 and this schema on read is applied, not on write. Query and processing. So interactive ANSI SQL. Scaling is automatic because it's totally serverless and best for ad hoc. So ad hoc means whenever there is demand, you just do an exploration. You don't keep it running all the time. Log analysis, serverless data lake querying. Next, Amazon Redshift. It's a petabyte scale data warehouse. It's like a massively huge data warehouse. So there's only one. So any warehousing question comes, it should be easy. Redshift. Unless there's some additional information that you have to change your answer, but Redshift should be easy actually. Data location, it's stored within the cluster or Redshift managed storage. So it has its own storage. Query and processing, interactive SQL. Cluster nodes are all Redshift processing units. Best for enterprise business intelligence, complex SQL analytics and data warehousing. It's very fast. It can serve data much faster than Athena, and this is to power your basically dashboards which are like mission critical and you want to show some information like non-stop as it being changed, or you want to run some queries, analytics like massive, huge ones. Redshift Spectrum. So primary purpose query S3 data from Redshift. So basically it joins S3 as well as Redshift. Data location S3, queries in place. Query and processing, so it's an extension of Redshift and it uses Redshift cluster. So for compute, it will use Redshift cluster resources. But data can come from both S3 plus Redshift. And it's best for extending data warehouse to data lake and hybrid queries. Next, we have Elastic MapReduce EMR with Presto or Spark SQL. So this is interactive analytics on big data platform. Data location you can keep in S3 or HDFS or various sources. Query and processing, SQL dialects, manual cluster sizing, and it is best for advanced customization, specific frameworks and large scale processing. So you will go only if there is a some kind of coupling with or tight interaction with HDFS platform, Hadoop platform, Apache Spark. You want to provide some kind of querying, then only you will choose this option. But most of the time you will either go for Athena or Redshift. So this is a special case. Okay, so let's say some company is migrating and all, and they are stuck with Hadoop, Spark, Apache Spark and stuff. So you will choose this. Okay, next, data processing and ETL services comparison. So first, so some of the services may repeat because they are falling under different categories and they are serving the same purpose under different features like business requirements, I can say. Okay, Glue. So primary purpose serverless ETL and metadata management. Processing model is primarily batch ETL, extract, transform, load, batch, and it supports streaming also, but primarily it's a batch based. So key components are data catalog crawlers. So basically catalog is data metadata of all your data sources from all S3, all those things. Then ETL jobs are there. Basically you can schedule or run ad hoc jobs. So basically you have a big pipeline, you can run those pipelines. It can take data, do multiple transformation and finally store at some destination. And data quality. So best for serverless ETL. You can have schema discovery because you have a data catalog, and metadata management. So basically from here you can see all your data sources and what kind of schema, number of columns, all those things you can identify. Next, Amazon EMR. Primary purpose managed big data processing platform. Processing model is batch, streaming and interactive. It supports all three. Key components. So it's a cluster based service. You have applications which are Hive and Spark. Apache Spark is very popular. And you have steps also. Best for big data processing, machine learning at scale, and custom framework needs. So every time there is custom framework needs, and you have some kind of coupling with Apache Spark, Hive, and some other service, big data service, then you can use this. Then next comes Kinesis Data Analytics for SQL. So, primary purpose SQL analytics on streams. Processing model is real-time SQL, analytics, and legacy. Key components SQL applications, and this is a Kinesis processing units based scaling. So how it scales, and best for simple stream analytics with SQL. So currently this is a legacy service, but in the exam it may show up. Next we have AWS data pipeline. Again, this is also legacy service. Primary purpose was batch workflow orchestration. Processing model was batch processing, and so it's a legacy service. Key components data nodes, activities, resources, and schedules. Best for legacy batch ETL, not recommended for new workloads. Next, AWS orchestration services comparison. First one, AWS step functions. So this is the new successor to any kind of orchestration service compared to data pipeline. So primary purpose, general purpose workflow orchestration. Definition method, so you'll use a visual editor or JSON, and it has a own DSL language, domain specific language. Then workflow types, you can have standard, which are basically exactly once workflow. Express, which at least once, so it will run at least once or more. Exactly once will be, it has to like make sure it runs only once and not more. And it can have up to 1 year duration, so it can wait, and you can have some kind of condition, so it can last almost a year. And best for microservice orchestration, ETL coordination, and service integration. Next one, Amazon managed workflow for Apache Airflow. Okay, so this is managed Apache Airflow service. So Apache Airflow is a very popular framework, open source framework for orchestration, and Amazon provides this on their own, so you don't have to spin like create EC2 instance and install the software. You can use directly. And important thing, it has its own language, and it's written in Python. So there are Python directed acyclic graphs, DAG files, by which you create this all these workflows. So every time there is some dependency on legacy service and Python, just remember it does not support other things. So choose this only when these two things are being called out. Okay, workflow types, DAG based workflow based on task configuration. Best for complex pipelines, Python defined workflows. Next one, Glue workflows. So Glue also had its own workflow system also. So primary purpose, Glue specific workflow orchestration. And definition method, you can have visual, so you can visually define this workflow by putting like boxes, arrows, all those things, and you can do this via APIs as well. Then workflow types, DAG of Glue jobs, then you have Glue crawlers, simple predecessor, successor. So this kind of simple predecessor and successor means before and after. You can define those by just drag and drop of creating this kind of workflow. And best for simple Glue ETL orchestration. Next, AWS data pipeline. So it's a legacy batch data workflow service. Definition. So we use JSON pipeline definition. So basically we edit the JSON, or we can directly work with JSON. Workflow types, batch scheduled workflows, and simple dependency chain. Best for legacy ETL and not recommended for any new projects or implementation. Data governance and cataloging services comparison. So first one, AWS Glue Data Catalog. Primary purpose, technical metadata storage. So user focus, basically who are the audience, data engineers and developers. Metadata type, technical schemas, tables and partitions. And it is best for central metadata repository and catalog for AWS analytics services. Next, AWS Lake Formation. The primary purpose of this service is data lake governance and security. User focus, so audience is data engineers and security admins. Metadata type, security permissions, fine-grained access control. Best for data lake security and providing fine-grained access control. So basically underlying data is S3. So if you go through a lake formation, it will create a layer of security on top of S3. And you can have all kind of like this table, this column, this row. So you can go very granular and you can assign at this level, because this cannot be done directly at S3. Next, Amazon Data Zone. Primary purpose is business data discovery and governance. User focus, basically audience is business users and data stewards. Metadata type, business glossary, data products and projects. So basically in data zone, you create these kind of objects and you work with these glossary products and projects. Best for business oriented data discovery and self-service governance. Next, business intelligence and visualization service comparison. First one, Amazon QuickSight. So the primary purpose is cloud native business intelligence. Data engine, there is a Spice in-memory proprietary data technology or direct query. User types, so we have authors and readers, so they are part of standard and pro version. Visualization types, you have standard business visualization and paginated reports. Data sources, there are 40 plus sources including AWS services, SaaS and databases, and this list is growing day by day. Embedding capabilities, you have full data dashboards, you have visual embeddings and APIs. There's some ML features also. You have anomaly detection, forecasting, Amazon Q natural language service integration. So Amazon Q is another service which it integrates with, and it's best for AWS integrated BI. Embedded analytics, pay per session model. Next, Amazon managed Grafana. So QuickSight is the oldest. This managed Grafana is quite recent. So primary purpose, operational dashboards and monitoring. Data engine, time series focused. User types, you have the audience is technical users or the DevOps teams. Visualization types, so you can have time series, you can have logs visualization, you can have traces and visualization trace. Data sources, 30 plus including AWS services, and Grafana and Prometheus, it's a very well known pattern in the industry, and you can have integration or the source CloudWatch also. Embedding capabilities, you have dashboard embedding through iframe. Iframe is basically an HTML technology where you can show on your portal at one of the HTML iframe box. ML features, so you have limited but it's visualization focused, and best for operational monitoring, technical dashboards. So in DevOps team, this is used through Prometheus and Grafana. Basically Prometheus scrapes or gets all the data and Grafana shows all the graphs. Next, search and log analytics services comparison. So Amazon Open Search service. So it's similar to Elasticsearch, but there is a fork and they call it Open Search. Primary purpose, search, log, analytics and observability. Architecture, there's a managed clusters or serverless. So both options are there. Query capabilities, so you have full text search. Basically, you don't have to create indexes and all, and you can just do a full text search. You can just dump the data. You can have fuzzy search, you can have geospatial spatial search and vector search also. Scaling model, instance scaling or open search compute unit based based scaling also. So it's open search compute unit OCU. Okay, use cases, full text search, log analytics, CIAM, basically it's like operational monitoring and vector search. Integration points, S3, Firehose, CloudWatch, Kinesis data streams. Limitations, so there's a management overhead for provision clusters. Next, CloudWatch logs insights. Primary purpose is interactive log analysis. It's a managed service. Query capabilities, log, field extraction and pattern recognition. Scaling model, automatic. Use cases, interactive analysis of CloudWatch logs. Integration points, CloudWatch and Lambda. Limitations, limited to CloudWatch logs only. So basically this reads from logs and then provides insights, and it's not full featured search. Specialized analytics services. First, AWS clean rooms. The primary purpose is secure multi-party analytics. Key capabilities, cryptographic computing and differential privacy. Use cases, multi-party data collaboration, privacy preserving analytics. And integrations are S3, Glue and Redshift. Pricing model is collaboration, compute, queries and storage. Basically, multiple AWS accounts or different AWS accounts can collaborate using clean rooms. So multi-party can collaborate and share their analytics through this. Next, AWS entity resolution. So primary purpose is match and link related records. Key capabilities are rule-based matching and ML matching. Use cases, customer 360 views, record deduplication. Integration points, S3, Glue, identity providers. Pricing model, workflow run hour and records processed. Next, Amazon Time Stream. Primary purpose, as the name suggests, it's totally for time series database. So basically data which you generate some data, but the main thing is you will always have timestamp in that. It can go to microsecond, nanosecond, whatever, and you will have another like rest all data along with the time. So that is the most important thing. Key capabilities: time optimized storage tiers. Basically, you can move from one tier to another tier depending on how much time has passed. So use cases: IoT data, so Internet of Things, because it generates data non-stop. Monitoring matrix and time series analytics. Integration points: IoT core. There's another service, IoT core. Then Kinesis data streams and Lambda. Pricing model is storage per hour based, processing based, and the query based also. Next, AWS Data Exchange. Primary purpose: it's a data marketplace. So basically, you will publish or buy data assets through data exchange. Key capabilities: so you can do discovery. So basically, you can go and discover if somebody wants to sell their data assets. You have a subscription model. So basically, you pay either one-time fees or monthly fees, and you will have a delivery also. Basically, through data exchange, you can deliver to your customer or some other party, or you can get from them also. Use cases: finding and using third-party data. Integration points: S3, Redshift, lake formation. Pricing model: provider fees and AWS fees. So basically, AWS will take some commission and provider will charge their own fees. And integration points means they will sell their assets which can be in on S3. So basically, that's the most common way to sell. So that data must sit in some service, right? Or data can be in Redshift, or it can be sold via lake formation. Basically, lake formation assets. Data storage and format optimization comparison. So this will just be like quick on type of data. So format, first is S3, which is the storage service, and data is, let's say, in CSV and JSON. It's best for simple compatibility and human readable. Query performance is poor because if you do a full scan, it's quite poor, the performance. Storage efficiency is also low because it will take a lot of space, and compute also. AWS service support. So all AWS services support this CSV and JSON. So trade-off is easy to use but inefficient for analytics. Next, S3 Parquet. It is best for all kind of analytical workloads. Query performance is excellent because it's there is a columnar based data. Storage efficiency very good. AWS services which support are Athena, Redshift, Spectrum, EMR, and Glue. Trade-off: optimized for analytics but less human readable. Basically, you cannot read directly from Parquet. You have some reader and all, but you have to use those specialized readers. Then S3 ORC. It is best for Hive workloads. So if you have Apache Hive, then it's compatible with ORC. Query performance is excellent, and you have column pruning. Storage efficiency very good. Service support all Athena, Redshift, Spectrum, EMR, and Glue, all four. So trade-off similar to Parquet but better for Hive and Hadoop workloads. Next, S3 with partitioning, best for optimized query performance. Query performance is significantly improved. Storage efficiency is neutral. All query services support this, and trade-offs requires partition management. Next, we have Redshift internal. So it is best for data warehouse queries. Query performance excellent for configured workloads. Storage efficiency good. It's a columnar based data model. It provides compression. AWS support, service support only Redshift, and trade-off: it's fast but requires loading. So you have to load data beforehand in Redshift. Next, we have Spice. This is for QuickSight, and it is best for BI dashboards and visualization. Query performance very fast for the prepared data. Storage efficiency, in-memory data model, and capacity cost. Only one QuickSight is supported. Trade-offs: fast visualization but limited capacity. Next, we have Kinesis streams, and it is best for temporary stream retention. Query performance not applicable. Basically, it's a streaming. So storage efficiency is medium. Like basically, this is a retention. So 1 hour to 365 days. And AWS service support only KDS consumers. Kinesis data streams consumers can read this data. Trade-offs good for replay but time limited. Next, last section, exam focused decision metrics. So which service to choose based on what you see in the question. First, ad hoc SQL queries on S3 data. So first, if Athena is there, choose that. Second, if Spectrum is there. So key distinguishing factors are Athena, there is no infrastructure, you pay per query. Spectrum, next, if the second option, it is extension of existing Redshift. Common exam distractors, EMR Hive, more complex than needed. So we don't have to go to Hive. Next, scenario key phrase will be something like data warehouse for BI reporting and primary service only one, Redshift. Key distinguishing factors are MPP architecture, massively parallel processing, performance for complex analytics and BI tool integration. Common exam distractors can be RDS, OLTP, not OLAP. So OLTP is online transaction processing, not analytics. So there's a difference between transaction and analytics. Transaction is like row by row data is stored, and analytics is like column by column, because when we do analytics we actually are interested in columns, not at every row. Then there could be other distractors like DynamoDB, which is NoSQL but not analytics. Then we have real-time stream processing with state. Primary service that you should choose is managed service for Apache Flink. Next, secondary option, Kinesis data analytics for SQL. So key distinguishing factors are Flink, it can complex state, it can keep its state, the state management is there, exactly once processing is there. And for KDA SQL, you have simpler SQL approach. There could be distractors like Lambda, which lacks sophisticated state management. Next, ETL jobs with matching infrastructure. So primary service only one, luckily AWS Glue. ETL means glue. Like just remember these keywords. So some features or the factors are serverless. It has integrated catalog. It has a visual builder options. So you can build those ETL jobs by drag and drop. And there could be some distractors like EMR, which requires much more management, or Lambda, where this is limited for complex ETL. Next come Apache Spark processing. So if Spark is mentioned or Hadoop, you go with Amazon EMR. Secondary, you can still go with AWS Glue because that also have some limited support. EMR, you have total control or more control, and there are a lot of frameworks supported. Glue, which is simpler but serverless. Exam distractors could be EC2 with Spark. There is too much of management. Next, stream data delivery to S3 or Redshift. So just choose Kinesis data firehose. There is a zero code delivery and there is a managed scaling as well as buffering option. So this will like buffer Kinesis data stream plus target. So just remember, common exam distractors are Kinesis data streams because that will require consumer development. So development in the sense, if you want to deliver to S3 and Redshift, data firehose, you don't have to do anything because this is inbuilt. But if you do data streams, you have to build that the consumer endpoint, all the processing to finally save the data to either S3 or Redshift, and this consumer must be running all the time. So this you can avoid. Next, business dashboards and reports. So primary service only one, luckily Amazon QuickSight. So key distinguishing factors are purpose built for business intelligence. There's a Spice engine and there's machine learning insights as well. So common exam distractors are managed Grafana, which is more technical and operational. Next, data lake security and governance. So if key phrase are these, then go with lake formation. Secondary options you can still do with IAM policies only, but which will be take much more engineering. So key distinguishing factors of lake formations are fine-grained access and you have central permissions model. Common exam distractors are direct S3 permissions, which is too complex at large scale. It's not scalable. Next, Apache Kafka related workloads. So straight away go with Amazon MSK. Key distinguishing factors, native Kafka compatibility, and you have MSK Connect framework also supported. Common exam distractors can be Kinesis, which has different API, and these APIs are not Kafka compatible. Kinesis have its own producers and consumers. They have totally different APIs compared to Kafka. Then Python based workflow orchestration. Just go with Amazon managed workflow for Apache Airflow. So workflow for Airflow is the any Python based workflow orchestration. So key distinguishing factors are Airflow compatibility and DAG, directed acyclic graph-based workflows. Some exam distractors can be step functions, state machine, not Python-based. So that is the different thing. Coordinating AWS services. So only one option, luckily, you can go with AWS step functions. So key distinguishing factors are visual workflow, you have native AWS integration. Common exam distractors could be, again, managed workflow for Apache Airflow, which is more complex for simple AWS coordination. Log, analytics and search. Only one service you have to choose, Amazon OpenSearch, which is your primary service. Secondary, you can still go with CloudWatch Logs Insights if the first option is not in the answer. So key distinguishing factors are full text search, visualization and machine learning. Exam distractors can be Athena. It can query logs but not optimized for search. So this can be an answer if first, second are not there. Basically OpenSearch and CloudWatch Logs Insights are not there. Then self-service data discovery portal. Primary service you have to choose is Amazon Data Zone. So if that is present, choose that answer. If that is not present and you have to choose two or all the first is not present, then Glue Data Catalog. So key distinguishing factors are business-oriented catalog and user-friendly portal. Common exam distractors could be Glue Catalog, which have technical metadata, but it's not business-oriented. And that's all. Thanks for watching.